Hello, everybody, and welcome to our talk, AI Systems for Accessibility. I am thrilled to be speaking here for a second year in a row about AI and machine learning in the field of accessibility. Last year, we introduced you all to our AI Systems for Accessibility, and this year we have some amazing new advancements to share with you all. For those of you who don't know me, my name is Noé, and I've been a machine learning engineer for over 4 years here at Deque. This year, I'm very excited to be joined by Dylan.
Hey everybody, my name's Dylan Sheffer, and I'm an accessibility coach turned AI accessibility engineer here at Deque.
In today's talk, we will cover how we are using AI to enhance digital accessibility for good, with an emphasis on human-centric AI systems. We believe that, because of the sheer importance of accessibility, adoption of AI must be done carefully and with a special focus on eliminating false positives or the ability to introduce issues. Here at Deque, we are working hard on delivering AI systems that help humans while leaving them in control. Today, we will recap our systems from last year, and then we will briefly touch on the AI landscape over the past year and how things have changed, because I'm sure a lot of you are aware they have changed quite substantially in the past year. And then we will dive into how large language models like ChatGPT roughly work at a high level. And once we have that understanding, we will discuss the implications of how they're trained and how they work for accessibility. And then based on that, we'll discuss where we envision these technologies being applied in order to aid building a more accessible digital world. And then we're very excited to demonstrate 2 groundbreaking new AI systems that we have and that we're working hard on here at Deque. And at the end of the talk, hopefully we'll have some time for Q&A where we'd love to answer any questions you all may have. So before we get into AI today, it's important to look back on where we were last year and where we've come since then. Last year, during this same talk, we talked about our state-of-the-art proprietary computer vision algorithms and the data pipeline that is responsible for powering it. For those of you who aren't there, or for those of you who need a refresher, this fast and efficient computer vision system allows us to identify, on a purely visual basis, user interface elements. This allows us to identify the components based purely on visual semantics, kind of how like a sighted user would. And then we take these detections from our computer vision system and compare them for discrepancies in the markup. This system is powered by a continuously updating data pipeline and a unique computer vision algorithm that encodes the relationships of objects to one another. And this capacity is already in use a few places at Deque. The first of those is in Axe DevTools Pro, where we have a number of intelligent guided tests. We leverage this new ability to pinpoint potentially interactive and structural user interface components on a given page based on their visual appearance alone. This allows us to find more potential accessibility issues without the risk of introducing false positives. Because of the way we guide users through the test, we allow them to remain in control while making their lives easier with our machine learning based detections. So the first place in Axe DevTools Pro where we use this is in the elements in intelligent guided test. And this basically looks at all of the interactive components such as buttons, tabs, and inputs, and compares the detections from our computer vision model to what is present in the markup. And the second place in the tables intelligent guided test, which checks the markup of table rows and headers and makes sure that they're marked up properly and able to be interpreted by screen readers. Another example of where we use this is in our Figma plugin, Axe for Designers. This integration enables designers to quickly and accurately add accessibility annotations directly to their designs. Using our computer vision system, we provide suggestions for accessibility annotations for different landmark elements, and we even have automated tab index markers. Again, all of this is based purely on the visual presentation. This helps make accessibility a priority from the beginning of the software life cycle without requiring all designers to be accessibility experts. Our data shows us that the majority of accessibility issues actually originate in the design step. So if we can address them during this phase, we can prevent a lot of accessibility issues from even making it into development. And we are so proud of what we've been able to accomplish with AI and computer vision in such a short amount of time. However, as you all know, things have changed quite dramatically in the last year. And here at Deque, we're working on making sure that we adopt these changes in a way that makes sense. So in the last year, I'm sure you've all heard a lot about AI, and it's expanded quite dramatically beyond the tech community, touching on everything from ethics to creativity. Artificial intelligence has gone from a niche subject kind of looming in the distance to something that is an everyday subject with very real implications. And central to this shift has been the emergence and further development of large language models, which you'll hear me refer to as LLMs throughout the course of this talk today. The most common and most popular of these is called ChatGPT, but there are a variety of others that are being produced by other companies, and their capabilities have sparked wonder and debate across a variety of different sectors. And for the field of accessibility, we here at Deque believe that this represents a pivotal moment. It is very important to get it right, but the potential of these models is tremendous. They bring us closer than ever to the point where we can have technology that is truly person-centric. Technology that not only has a tremendous wealth of knowledge that it can pull from, but is also able to conform to the needs of the individual and meet them where they are at, instead of the other way around. Large language models unlock the ability to build complicated systems, execute functions and actions, write coherent code, and so much more. The ability of a large language model to understand and produce human-like text and code offers unprecedented opportunities for improving accessibility tools and services. However, it's crucial to acknowledge that while they are a significant leap forward and they do have a significant amount of potential, they are not without their challenges. They're not infallible. They're prone to making up information, which is referred to as hallucinating in particular circumstances. And as a result of the way that they are trained and the information that they are trained on, which we will go over in a second, they contain biases that prevent them from producing accessible results by default. But with careful consideration, as we'll show you, these pitfalls could be avoided while still reaping the tremendous benefits of these models. But before we can get too deeply into how the current landscape applies specifically to accessibility, it's really important to make sure that we all understand at a basic level how they work and where the data that they're trained on comes from. So most of you may have heard that large language models are just text predictors, sort of like the autocomplete in your phone or in your email app that helps you finish your sentence. And, at its very core, that is essentially true. They are just text predictors. They take in information from a user, known as a prompt, and then they apply their understanding of the world based on their training set in order to predict the most likely completion, as it's referred to, for that input. They operate on the same fundamental statistical and mathematical principles that all other deep learning models also operate on. And so we've all seen prediction models before, so you're likely wondering what makes large language models unique and more powerful than the ones we've seen before. Well, these systems are interesting and powerful because of a combination of their training set and how they are trained. The ability to train them in this way is a consequence of improvements in algorithms and computing power. Their training process is unique because they've been fed a tremendous amount of data from human written text and code from a well-known comprehensive data set. This data set is what is referred to as the corpus. The corpus is a set of data that encompasses most of the publicly accessible information on the internet, so things such as entire books, academic papers, blog posts, source code, and so much more. They've been trained on writing across a variety of different styles, fields, and genres. And yes, that includes accessibility. During the training process, the model uses statistical techniques that group words together based on the context and the frequency in which certain pieces of text are seen together. This means that things that are similar in concept or theme are grouped together during this process. And so when this has been done at a sufficiently large scale, the statistical model produces what you can essentially think of as a large graph comprised of many, many different points and many dimensions. This is essentially a mental model of how things are related, and it implicitly encodes the meanings of words and phrases. The points on this graph represent the words, ideas, and concepts that the model came across during its training, and the graph's dimensions represent the different contexts in which these points were seen. And remember what I just said a moment ago. These points are positioned more closely to one another based on the meaning and context in which they were found together. So this results in a graph that is grouped together not by language or by alphabetical order, but it's positioned in space by the meaning that our words and our phrases represent. And so this means that we've created a system that can capture the depth, context, and nuance of human language. But also, we have found a way that a computer can measure relatedness of information based off the distances between the points in the graph. And so this results in a technology that can capture, interpret, and produce the depth and nuance of human language. And Dylan has several great examples that I think will help make this all a little bit more clear.
All right, so here's a little example of ChatGPT-4 demonstrating this contextual understanding by presenting it with a task of defining a phrase in two different contexts. So the very first example I have is a story about my little dog named Basil and how she ate all my banana muffins as they were cooling on a table. When I discovered that this happened, I began to scold her, but I couldn't be super serious because she was so cute. The other example that I provided ChatGPT was some song lyrics from one of the pop greats, Charlie XCX. Charlie's song is about reflecting on a misconnection with themes of needing to be unapologetically oneself and exuding self-confidence. And the phrase used in both of these stories is bad girl. So I have the full chats in the slides after the conclusion just for future reference, but for time's sake, I'm just going to summarize these conversations. But as you can imagine, bad girl means very different things in these given contexts. And traditional computing struggles to utilize that surrounding context in order to fully capture that meaning. However, this isn't a problem at all for LLMs. In Basil's stories, ChatGPT defines bad girl in this context to affectionately express disapproval. And it got this from my reaction to the situation and how Basil is obviously not very bothered by the scolding I was giving her. And then the other example I have in Charlie XCX, constant repeat, ChatGPT is defining a bad girl in this context as one who is both self-confident and self-assured while remaining desirable and captivating. And for anyone else who listens to Charlie, that's spot on. However, this contextual understanding is only a singular part of the human-centric software puzzle. The other part that I want you all to think about is how large language models can adapt to the users who are actually using them. So this adaptation is done through prompting changes, like asking it to role play or to output its responses for a given audience. In this task, I'm asking it to define the word perceivable in terms of P-O-U-R, or in case you're not familiar with POUR, it stands for perceivable, operable, understandable, and robust, which are the main principles behind the WCAG. And since I'm talking to GPT-4 and it's been trained on all this accessibility terminology, that is all I need to really provide it, and it understands what I'm talking about. So for any good experiment, we have to start with a control. And for this control, I'm withholding some information from it. I'm withholding the role it should be playing, and I'm withholding the audience that it should be outputting. We then get the definition that perceivable in this context is an accessibility principle that focuses on ensuring a user can perceive the information being presented. It also is saying that perceivable is about making web content accessible through a user's senses via any assistive devices they may need. So that's a good output, but they're a little technical for certain audiences, but it's a good answer overall. Now that we've established that control, we can move on to adding a role into this prompt. We're going to go with the same task, but this time I'm asking it to act as an accessibility expert with a focus on the web content accessibility guidelines conformance. And in its definition now, it's saying that perceivable is the first principle of POUR, which is one of the main principles of the WCAG. Then it's going into how information and UI components must be presented in ways that all users can perceive them regardless of how they perceive. And then finally, it goes into the details of the guidelines and the very specific success criteria like text alternatives, accounting for time-based media, etc. Now, that is exactly what you'd expect from an accessibility expert discussing this. But not everyone is an accessibility expert, and not everyone is going to understand the jargon that comes along with technical explanations. And this is where audience adaptation comes in. So let's finally move on. What happens when we introduce a target into this? So this example uses the same task and it's using the same role, but I'm telling it to output its responses as if it were speaking to an accessibility beginner. In this definition, it decides to go into a metaphor, comparing the web to a whole buffet. And I think this is a perfectly valid approach, and it's actually kind of creative. It explains that the perceivable principle is like ensuring that each dish is presented in a way that every guest can see, smell, and find information about the dish. Then it relates it back to accessibility by showing the parallels with image descriptions. Finally, it concludes with a definition in simpler terms that relates both web accessibility concepts to the overarching metaphor. This example illustrates that with proper prompting, you can make a model play a given role and address its audience at the specified experience level. This is an incredible new set of capabilities that we've never really seen before in tech. However, these capabilities aren't without their challenges. So I'm going to pass it back to Noe to discuss the challenges for accessibility specifically in these systems.
Thank you, Dylan. So now that you all have some understanding of how the model uses context to understand things, and you understand where the data that they're trained on comes from, you might be thinking that this sounds perfect. Why don't we just take these models and have them automatically fix all the accessibility issues out there? After all, the model is trained on all of the information on the internet, and it can understand and capture the context, subtleties, and nuance in human language. I think as Dylan's examples showed, it is very good at understanding and explaining the context that phrases appear in, much better than anything we've seen before. And we've also demonstrated its ability to adjust the presentation of this information to a given audience. However, there is a double-edged sword that comes with this. Because the model is trained on all of the information from the web, that unfortunately means that it also inherits all of the biases that exist on the web. And if you attended either of the keynote talks this morning, you'll know this pretty well already. And what this means for the world of accessibility is that by default, base models like ChatGPT will most likely output the same biases and accessibility mistakes that the majority of its training data contains. It is a prediction model after all, and its job is to produce what the most likely response is based on its past training data. And when it's seen a lot of accessibility issues, we know that it's going to be outputting a lot of accessibility issues. So because we know that we can't trust the accessibility of the code on the internet, we also know that these models will predict to complete a particular input. The base output from the models is just not going to cut it. But there is hope. The models are incredibly adaptive. They could listen to a command such as act as a digital accessibility professional with a focus on WCAG performance, which would result in all messages that follow to be framed from that exact same perspective. This would cause it
Dylan, do you maybe want to take over? Okay, wait, we got Noe back, actually.
Hello?
Okay, great.
Okay.
Yeah, let's start from the beginning.
Okay, so there is hope, however. These models are incredibly adaptive. They could listen to a command such as act as a digital accessibility professional with a focus on WCAG performance, which would result in all other messages to be framed from that perspective. And then they'll output all the messages framed from the perspective of an accessibility expert, which would make them more likely to consider the accessibility implications of a given input prompt. This is possible, again, because the model is trained on the entire internet, which includes topics like digital accessibility. It just requires a little bit of a nudge to move beyond the generic and biased output it has by default to something that can actually be worked with. In addition, the model can be supplied with custom information and be instructed to follow a specific chain of commands to help tailor its output to be more reliable and trustworthy. In reality, it is a little bit more complicated than that to get the model to output more reliable information, but now you at least understand the justification for why we believe this is possible. And even with well-designed prompts, the model is liable to occasionally still make some mistakes, though many times less often than the default models without the specific prompting and usage. And this is why it's so important to design our systems in a way that is human-centric and meet the person where they are at. and with a special focus on eliminating the possibility of supplying false information and misguiding the user. So again, if you attended either of the keynote talks this morning, you will all be familiar with how these models can still be used in a human-centric way. If we make sure that the human is in control, these models can make people's lives significantly easier, both in terms of development and also as a learning tool, without the possibility of introducing issues. So now we all have a pretty good understanding of what large language models are and what their strengths are compared to previous prediction models and natural language processing systems. We've also discussed their weaknesses and potential for bias in their training set, and the flexibility for how within large language models and how that allows us to overcome that bias. So now you might be thinking, where do large language models fit in within the world of digital accessibility? And Dylan Sheffer is going to share his insights from his time as an accessibility coach and why a human-centric approach is so important for accessibility.
So this question of where we see models fitting into the world of accessibility is a question I've thought about a lot. And this is kind of where I've landed at this point. So the current situation that we're in is that the world that we live in is flawed. The people that are tasked with designing and developing our digital infrastructure hasn't been trained sufficiently on accessibility. This has created a cycle in which people are unknowingly or knowingly creating experiences that largely exclude disabled people from them. Besides the obvious barriers this creates for disabled people, this also can result in organizations being hit with lawsuits that contain tight deadlines to fix these accessibility issues. This is necessary for actionable change to occur within most organizations. However, this is also an unfortunate situation in which many people begin their accessibility journey. It's stressful, it's embarrassing, and it's complicated. And accessibility is complicated because it relies on so much nuance and it relies on so much context for each individual situation that it's really difficult for somebody getting started to understand all of that. And this is all just because being a person in a changing world is nuanced and complicated, which just makes accessibility nuanced and complicated. Every single accessibility issue is rooted in all of our varying abilities and perspectives, and a single accessibility issue requires a ton of that knowledge just to get started. And I think this is kind of where AI systems for accessibility come into play. We can utilize the abilities of large language models, like their understanding of natural human input, with their flexibility in playing many different roles. Then we can combine that with Deque's world-class accessibility resources, tooling, and analytics. This creates a system in which developers and designers and product owners are met exactly where they are in their accessibility journey, and we can provide those tailored experiences for their specific needs. This is in contrast to the current system in which people must read through many courses and pages of documentation in order to hope that they have the information that they need, and additionally hope that they're able to correctly apply it to their particular situation. Even worse, people starting out might not even know what questions to ask in order to get started. This is an issue that prevents real change from being made within organizations and can result in people becoming ultimately frustrated by accessibility, which is not a beneficial situation for anyone involved. So since we can't necessarily address the root issue alone, our next best bet is to try to create systems that can meet people and organizations where they are in their accessibility journey. So announcing for the very first time, we're here to announce 2 brand new human-centric AI accessibility applications by Deque. I'm here to announce Axe Advisor for Deque University and Deque's AI Accessibility Remediation Assistant for Axe Dev Tools. And to discuss Axe Advisor for the very first time, I'm passing to Noe.
Thank you, Dylan. Axe Advisor is our attempt at creating a personalized accessibility tutor that is able to adapt our body of knowledge about accessibility to both the user's individual level and can adapt to particular situations that a user may be in when provided with that context. This learning assistant is integrated directly into Deque University. It allows for users to learn and feel comfortable asking questions that they might otherwise feel afraid that would sound stupid or they might be embarrassed to ask. And there might not be a very specific or explicit direct answer out there to their question, and this allows them to get that. And most importantly, all of our answers are rooted in Deque University's course content, and it even cites responses for both peace of mind, and it acts as a springboard for further learning. So we know we can trust the output of the models. And so I'm very excited to demo Axe Advisor. So here's a sneak peek into Axe Advisor for you all. Before we show you the example, I want to give you an overview of what you're going to see. We are showcasing an example where an accessibility beginner asks a question that they might be embarrassed about. Axe Advisor recognizes their tone, reassures them, and then proceeds to give a detailed answer to their question at a basic level of understanding. Most of the things that it says are backed by citations to real Deque University courses. All it takes is one click, and the user will be brought to a course written by our own accessibility experts that they can read to further their learning. This ensures that Axe Advisor meets the user where they are in their own personal journey and also provides them with trusted resources that they need to continue their own learning journey. So in this example, Axe Advisor, you can see, greets the user with, "Hello, I'm Axe Advisor, a chatbot developed by Deque Systems. I'm here to help you with your accessibility questions." The user then says, "So this may seem like a stupid question, but how can people use a website if they can't see them or use a mouse to get around?" Axe Advisor then responds with, "Not a stupid question at all." And then it proceeds to break the question down into its multiple parts. First, it addresses how blind users use screen readers to navigate. It then links to a Deque University course called Design Considerations for Blindness. You can click on that link and read more about it if you want. It then covers how people who can't use a mouse may use voice recognition software to navigate. After a thorough answer to that part of the question, it links a Deque University course called Design Considerations for Dexterity/Motor Disabilities. Again, the user has the option to click on this link and do more reading if they want. It then summarizes its answer and links several resources that the user can visit for further reading. All of this is done with a friendly tone and at a beginner level of understanding. As you can see from this demonstration, this is a judgment-free zone to ask questions, ranging from basic to complex. It can help with overarching design considerations or markup specifics. It can interpret and communicate changes in WCAG guidelines and explain nuances in digital accessibility that might otherwise be hard to get explicit answers to. And because it's relying on information written by our own accessibility experts, we know that we can trust it. So now, you might be wondering, how can I use this and when will it be available and how much does it cost? So we have a little slide on pricing and availability. We'll be announcing the pricing information soon, so please stay tuned for that. And in terms of availability, Axe Advisor will be open soon for a preview access. There's a QR code and a link on this slide for those of you who would like to get your hands on this as soon as possible. Please go ahead and enroll. We are so excited to hear your feedback on Axe Advisor. So now I'll hand it over to Dylan, who will wrap us up with two very impressive demos from our AI remediation tool.
Thank you, Noe. I'm so excited to show this off to you all. I've been working on this for a very long time, and it's so exciting just to show it off. So our AI accessibility remediation represents perhaps our most ambitious test for these new systems. This is going to guide the model through a process that uncovers the root cause of an issue through a combination of Axe core issues plus additional context that the model is able to extract from the code itself. Then it's going to determine the intention of the developer behind the code using all of the context clues within the code. Then it attempts to address the issue at hand while maintaining the desired coding style. And in addition to the attempted remediation, the application provides actionable tips and feedback to the user so that they'll have a better understanding of how to avoid the issues in the very first place. The goal of this system is to lessen that starting energy a developer would need in order to make meaningful impacts on their code base. Instead of starting them off with an error message and a link that goes to a help page that may or may not be directly relevant to their code, we are in the very least providing a first actionable step and tips on how to avoid that particular issue. And at most, this system is going to be enough to resolve the issue in its entirety. So to show this off, I'm going to show you a little video demonstration. These are examples from real websites that I found, and these are the literal responses from our model. In this demo, you're going to see input HTML and the process that the AI model is taking in order to address the issue at hand. I'm going to be playing the video and describing what's going on, and I may pause to add some additional context during the playback, so just bear with me. So to start this off, we have an input element. This input element here does not have a label associated with it, therefore it's failing an accessibility check here. So what are you? Well, some of the things that it has going on for this code is that there's some context clues in here. There's some information within the class that's indicating that it's perhaps for a promo code input. So we're going to pass this into the AI model and see what it comes up with. So first, it looks at that code and it begins to analyze it. Then in a moment, we're going to see what it's found out in its analysis. Now you can see it has pulled out some specific information here. It is listing out the determined developer intention. So it's deciding, oh, this does look like this is an input that is designed for promo code inputs. Then it's detailing what caused the issue itself. It's saying, hey, the label is left off and there's no ARIA attributes that are providing an accessible name to that input itself. Then it lists off all of the disability concerns that are related to this given Axe core issue. Mainly it's saying blind users are requiring screen readers to announce a field's purpose, and without that implicit name, or that explicit name rather, you're not going to be having that screen reader announce it. And then it's also going all the way down to mobility users might actually have their voice recognition software impacted by that lack of interactive, or that lack of implicit or explicit association with those given inputs. And then finally, it's presenting the user with tips for remediation, where it's suggesting, hey, why don't you use an ARIA label or a labeled by, or even better, how about use a native label element to address this issue? Once this analysis has been run, it is going on to move on to the remediation itself. So in a moment, you'll see the remediation pop up. But what's cool about our system is that before we're even presenting the user with any of these remediation recommendations, we're going through a multi-step process to validate these answers before presenting it to the user. We're checking it against the Axe Linter API to make sure that all responses coming out are addressing the issue at hand and not introducing any additional issues. But we're also sending it to another AI model that's just making sure, hey, can we get a quick sanity check here, and that the developer's intention is still met by the overall solution here. That way we can feel extra confident by the answers that we're presenting. And in one moment, we'll see two different recommendations here. This is because in this particular example, I have just asked the model to provide two different recommendations. One, I want it to output optimal HTML semantics, and the other one, I want them to output the minimum changes a developer would need in order to fix the reported issue. The semantic answer recommends that the developer use a native label element, and it also has gotten the programmatic association correct between the native label with its for attribute and the ID of the input element. Also, you should note that it is preserving all of the class names within all of the recommendations. That way, we're just easing that transition that a developer would need between the accessible code recommendation into their existing code base. For the minimal changes answer, you can notice that it's a little cut off over here, but we have the recommendation to add an ARIA label to the existing input, and that would sufficiently address the accessibility issue at hand. That, is the minimal changes that you would need, but it's not, the ideal answer in the best case scenario. But sometimes we have to be flexible with where the developer is coming from. What are the constraints of that individual piece of software? And this type of system allows us to meet the accessibility expectations along with whatever they need for their individual system. The next demo I would like to show off is an invalid custom heading. So this is going to be showing the same process as the previous example, except this particular example is an instance where a person likely styled a paragraph tag to look like a heading. If you can't see the slides, what we have here is a paragraph tag that has been given an ARIA level of 1. And inside of its inner content, we have some additional spans that have just increased the font size. And we're also adding in like a strong to make it bold, presumably. So that's all the information that this AI model has going into this, along with the Axe core issue. So again, let's go ahead and see what it does. So in the video, I'm clicking run, and it's saying reviewing accessibility issue. And we will see that scan take place for the developer's intention, the issue cause, the disability considerations, and the tips for remediation. And it is identifying that the likely intention is that the user was meaning to represent a hierarchical level, aka a heading. Then it's identifying the issue cause as a lack of support of the ARIA level attribute on a paragraph tag. Next, it lists out all the different ways with various disabilities rely on these needed semantics. And then finally, it gets to the tips for remediation, which is to either use a native heading tag or to use the appropriate role on a given element. Again, once these recommendations have been generated, we will be presented with the semantic and minimal changes, and all of those changes are going to be validated against AxLinter and our other AI model. And for the semantic recommendation, it's recommending, hey, why don't you just use an H1 tag? Come on. That'll just make it way more readable, but it'll also address that underlying semantic issue. However, if you don't have that ability, adding a simple role equals heading will allow you to have an element that will be presented as an actual heading element to assistive technology. And it's also fun to note that in the tips about this particular implementation, it is saying, hey, it is important to note that using a native heading element is generally preferred. That way, we're getting across, we know that you might not be able to do the best practice for coding in every single circumstance, but we want you to start being able to identify where you can start using native elements and help improve the developers' their ability to create inclusive code through the use of this tool. It's not only showing them what the solution is, it's telling them why and how to best approach it in the future. The availability for the AI accessibility remediation integration into XDev tools is still to be announced. It's still definitely in the works. However, you can stay up to date with any news and updates for this and anything Deque related on our news and resources page, linked on this slide, and by our lovely chat moderators. We really appreciate your patience for this integration. We're highly committed to making sure that this integration meets our high standards and that we are making the best overall experience with as low of issues as possible. And with that, thank you all so much for listening to our talk on AI systems for accessibility. I really appreciate you all taking the time to listen to our talk, and we'd love to answer any questions about AI and accessibility.
Yeah, thank you very much, Noe and Dylan. Wonderful presentation, and the questions are coming in. So first of all, I want to start off with one from one of our users. What kind of data does the AI accessibility remediations tool capture from a user that's using the tool?
Yeah, it's
So,
oh, do you want me to
go ahead, Dylan.
Okay. So basically what's going on is how the system's going to work is AxDevTools is going to flag an issue, right? And in that particular circumstance, we already have certain bits of information. We have that selector of the code that has caused the issue, and we have that issue that AxCore has flagged. We take that selector and we go ahead and select perhaps just like some of the surrounding context within the page and grab the necessary semantic HTML for the AI model to have enough context to kind of get enough context clues to be able to piece together what the developer is intending. That's all we're taking from the end user and supplying to the AI model, is just that little bit of HTML and the AxCore issue that flagged it originally.
Cool. Thank you very much, Dylan.
No problem.
I think this one might be a good one for Noe. Regarding Ax Advisor, how would people know that they're expected to signal their tone? I think they're referencing how you kind of prefaced saying, maybe this is a silly question.
Right. So we have a variety of different ways that we can do this. One is we can see how many different courses and how far along Deque University's curriculum a user is. And if they're just starting off, then we can start by answering in a beginner-friendly tone. And if we find that they're asking for follow-ups or for more detail often, then we can adapt the tone very easily. Also, we may just end up having a preference that people can set, kind of like a user setting where you can say your level of familiarity with accessibility, and then the model will automatically adjust its tone to that.
Awesome.
So you don't have to preface your own questions as stupid is kind of what I'm trying to say.
Yeah. Very cool. Thank you, Noe. All right. Folks are also curious about the AI remediation tool and if that will be built into Deque University or some other tool. I don't think it may be too early to say, but if you guys have any comments on that.
I would say it's probably too early to say whether it'll be built into the Deque University tool. Where we first see it being applied is within AxDevTools Pro. Just, because we are already in the browser, we're able to grab all that information that we need automatically, and we're already getting those issues flagged by AxCore. However, like we've said in our presentation, these systems are like almost infinitely expandable, and they can be adapted into pretty much any context you can really think. So I think we're in a really exciting position where we're kind of limited by our creativity and how we can apply these systems. So we're looking forward to creating more and more experiences that utilize good
And just
AI.
to add on to that, we have found that the Ax Advisor is relatively good at providing advice for, overarching design considerations or generating simple markup. But that's not its full intended purpose. So it will do that to a certain extent, but we would like to integrate things like the Ax linter and stuff into that before people are using it to generate a bunch of markup.
Awesome. Maybe on a related note to Ax Advisor, is it able to help users approach certain accessibility scenarios, such as providing alt text? They said they can't tell how many times they've seen text alternatives say something like "as seen below," when that's not really needed in your alt text.
Right. Yeah. So it definitely is able to generate alt text, and that's something that we found that it does pretty well. So if you're willing to copy and paste your snippet into there, it will probably do a pretty good job with it. And then it will also link resources for you to go on and read and learn more about providing good alt text yourself.
Yeah. What's really cool about it is that it's when you send this question of like, hey, is this good alt text? It's going ahead and it's translating that into some database query, and we're able to fetch all of the information within Deque University that has guidelines on creating good alt text. Then it's using all of those guidelines to help guide you through that process of determining whether this is a good way of generating, or good way of writing rather, these alt texts. So it's just really cool just seeing it utilize all of Deque's accessibility experts and all of our high-end documentation in order to provide natural language inputs and outputs between our users.
Absolutely. Awesome. All right. Regarding our AI remediation, popping back over to that one, what happens when the determined developer intention isn't correct?
Yeah, that's a great question. I think that's where we go into the human in the loop kind of thing, where, we heard that in the very first talk today, where if the developer is saying, hey, that isn't actually my intention, maybe I should just go ahead and stop that process and just try it again. I mean, like, why not? It's just a computer. So just say, hey, I don't think you quite got it right. Why don't you try it one more time? And we're playing around with this idea of being able to guide it through any sort of things, provide feedback to the process itself by being able to type to it, but we're still experimenting with that kind of input. We're hopefully just gonna get it with a nice linear process, but if we find that we need to be able to have a developer be able to type in, hey, I'm actually trying to do XYZ and you're trying to do ABC, then that might be the direction to go in.
Yeah, I think it's so important that we design our systems in a way that allow the human to be in the loop so that, if the model just goes down the wrong path with the developer intention, they can kind of course correct and then we can end up in the right place.
Yep.
Awesome. Yeah, very, very, very insightful answers to all these questions. Thank you, Dylan and Noe. I think we'll just wrap up with maybe one more question here. Julia is asking, can developers give feedback on Axe Advisor recommendation? For example, incorporating things such as company standards or setting recommendations to make it more precise for their use cases.
Yeah, absolutely. If those things are inputted to the model and into Axe Advisor, it will certainly consider those factors in giving its answers. And in addition to that, we plan on having the option to give feedback. So, if we find that we're not giving good answers for one specific type